We're going to show you a few things associated with silver chloride. First of all, we're going to make some silver chloride. We have silver nitrate solution here in this bottle, and we're going to add that silver nitrate solution to deionized water, and you can see that nothing really happens here because there should be no ions in the deionized water to react with the silver nitrate solution, so the silver nitrate solution is just diluted. So now I'm going to add this same solution to tap water, and you can see that the tap water becomes a bit cloudy here because there's a precipitate forming, probably between chloride ions and silver ions in solution, and maybe even some carbonate ions in solution and silver ions in solution. So in fact, this adding silver solution to water is a good way to test to see if the water is actually deionized or not. And you can see that obviously the tap water is not deionized. What I also have here are some samples of solid silver chloride that were collected years and years and years ago. They've been kept in a somewhat dark area, but the white has started to turn a little bit gray. But I'm going to accelerate this a bit by using long wave UV lamp here, and I'm going to shine it on this pile. I'm going to put this up in the corner here while I talk about some of the reactions involved. Okay, so what we have here is a reaction between silver nitrate in solution and chloride ions. So let's say our solution has some sodium ions as well. So let's just call it sodium chloride in aqueous solution. Okay, and what I'm writing here is a molecular ionic equation where everything is written as discrete molecules, whether they're ionic or molecular. Okay, and I can break apart strong electrolytes into ionic reactions, and so I'm going to show you a complete ionic reaction here. Complete ionic reaction or equation for this reaction. And these are considered to be soluble salts, and soluble ionic compounds get broken up into ions in ionic equations. And so this is silver ions reacting plus nitrate ions, nitrate ions plus sodium ions plus chloride ions. Okay, and we look to see if we can find any combination where precipitation takes place. I've already told you what we're actually looking for here, but go through this analysis. Sodium is a group 1 cation, and group 1 cations do not form insoluble ionic compounds, and sodium does not form a precipitate, so it goes through unchanged. Okay, nitrates. Nitrate salts are soluble salts. They do not form insoluble precipitates, so they go through unchanged. Okay, but what we have left, silver chloride. Many chloride salts or ionic compounds containing chlorides are soluble, but silver chloride is not. Okay, it's one of those exceptions. So silver chloride forms a solid, and this is what we're seeing here and what we can harvest and put here. Okay, now that we have this, we can go back and complete our molecular equation, and we could write solid silver chloride here, and the remaining ions here we can simply write as sodium nitrate, put them together, and write those as aqueous. But again, where we form solids, we put an S. Okay, now we can also say, well, what's the most important part? Okay, there are certain ions that do not participate in the reaction. Sodium ions do not participate in the reaction. Nitrate ions do not participate in the reaction. We call those spectator ions, because they just kind of look around and see what's happening around them. Okay, and so we can write a net ionic equation, kind of giving the net result, and they don't contain any spectator ions. And so we have, for a net ionic equation, is silver ions reacting with chloride ions to produce solid silver chloride. And again, that's that white precipitate. But the reason I have this sitting under an ultraviolet light is that upon exposure to sufficient light, the right wavelengths, you can see that the compound darkens. Okay, and the reason it darkens is because the energy from the ultraviolet light is enough to bounce electrons around in the solid, and actually what happens darkening is that these silver ions pick up electrons loosened by irradiation by ultraviolet light. They're coming off of probably the chloride ions, and the silver ions pick up electrons to become solid silver metal. Okay, this is an example of what we call a reduction half reaction, and turns out silver darkens pretty easily when it's exposed to light and other environmental factors. In fact, I got a little silver solution on my finger. You can see how it's dark on the tip of my finger where that solution darkened. But here we have ultraviolet light darkening the silver ions to produce silver metal. You can imagine how these types of reactions might find use in photography.